Hello everyone, I'm Christophe Paget. This week we will go through the launches of the week and the latest news on the space community, and that including the moon. This particular edition will be strongly emphasizing the Europe and the UK activities about space. I also introduced a brand new section, hopefully you will enjoy, related to the preparation on Earth of a lunar and Martian basis. But also we will be looking at what's happening at Starbase. On the 2nd of September 2023, ISRO launched the Aditya L1 on board of its Rocket Polar Satellite Launch Vehicle PSLV-XL from the Satish Dhawan Space Center in India. This satellite is en route to study the Sun from the Lagrange point L1 and weighs 1.5 tons. Aditya L1 is a satellite dedicated to do comprehensive study of the Sun. It has 7 distinct payloads. Aditya, in fact, in ancient language of India called Sanskrit, means the Sun. L1 here means the Lagrange point 1 of the Sun-Earth system. So L1 is a location in space where the gravitational forces of 2 celestial bodies, in this case Sun and Earth, are in equilibrium. This allowed the object placed there to remain relatively stable with respect to both celestial bodies. So effectively the Aditya satellite will rotate in circular orbit around this L1 Lagrange point. So Aditya L1 stays Earthbound orbits for 16 days, during which it will undergo 5 maneuvers to gain the necessary velocity for its journey. It will then undergo a trans-Lagrangian 1 insertion maneuver, making the beginning of its 110 days trajectory to this destination around the L1 Lagrange point. The final orbit will ensure an uninterrupted view of the Sun to study the solar radiation and magnetic storms before they are influenced by the Earth's magnetic field and its atmosphere. Moreover, the L1 Lagrange point is so stable that low effort is required to remain on such orbit, allowing the mission to last much longer. Aditya L1 will be approximately 1.5 million kilometers away from Earth, directed towards the Sun, which is about 1% between, of the Sun-Earth distance. So the Sun is a giant sphere of gas, as you know, and Aditya L1 would study the outer atmosphere of the Sun and will neither land on the Sun nor approach the Sun any closer, just to be clear on that. ISRO has been very active this year, and they have actually launched their 7th rocket, and this is effectively the 59th launch of a PSLV to date. The 2nd of September, SpaceX launched satellites for the Space Development Agency, which is a branch of the US Space Force, called Tranche 0B, because that's the second launch, from the Vandenberg Space Force Base in California on board of a Falcon 9 Block 5. Now, these satellites are destined to low Earth orbit at 950 km high with an inclination of 90 degrees, more or less. So the payload was 5 metric tons. Now there will be a constellation of 20 satellites to support the US Space Force in its mission to detect and follow ballistic missiles, and that includes hypersonic speed glider missiles, And this constellation will also be used to communicate within the US Space Force. Now, the first stage has landed for the 13th time, this time back to the launch site in Zone 4. On the 4th of September, SpaceX launched 21 satellite Starlink V2 Mini Group 612 on board of its Falcon 9 Block 5 to a low Earth orbit destination, and that was from the Kennedy Space Center Slick 39A in Florida. Now, the first stage flew twice and landed on the drone ship Just Read the Instruction somewhere in the Atlantic Ocean, and that was the 63rd flight of a Falcon 9 this year. On the 5th of September, Galactic Energy launched 4 satellite Tiange on board of his Series 1S. Now, that was the first time they launched from a sea launch platform near Heiyang in the province of Shandong in China. On the 6th of September, China Aerospace Science and Technology Corporation launched a remote sensing satellite Yuangang 3303 on board of his Long March 4C from his site Yungang Satellite Launch Center in China. On the 7th of September, JAXA sent successfully 2 satellite X-RIM to LEO and SLIM to land on the Moon on board of his MHI rocket H2A-202 from Tanegashima Space Center in Japan. That was the first JAXA mission of the year and the second MHI H2A rocket launch of the year. X-RISM is the X-ray imaging and spectroscopy mission, is JAXA's X-ray astronomy satellite, which will study the structure and formation of the universe and the outflows from galaxy nuclei and dark matter. So X-RISM will function as a next-generation space telescope in the X-ray astronomy field, following on from JAXA's previous astronomy satellite Hitomi, which was lost prematurely. SLIM, this time standing for Smart Lander for Investigating the Moon, is Japan's first lunar surface mission. The lander will demonstrate its ability to precisely land on the surface of the Moon, and the rocket H2A will place SLIM into translunar injection. Then, once the lander reaches the Moon, it will explore the surface of the Moon near the Marius Hills Hole, which is a possible entrance to a lava tube. On the 8th of September, Virgin Galactic launches its third galactic mission on board of its Spaceship 2 from Spaceport America with 3 paying guests, Ken Baxter from the United States, Timothy Nash from South Africa, and Adrian Reynard from the United Kingdom. ISRO has published a video of its Chandrayaan-3 flight just prior to landing, where you can see the moon surface beneath the lander. They have also published the latest steps made by his rover, Pragyan, coming out of his lander's wing, and the maneuver you see is that of Pragyan autonomously avoiding a crater. The laser-induced breakdown spectroscopy instrument on board rover Pragyan has made the first ever measurements on the elemental composition of the lunar surface in the South Pole. Now, this instrument, also called LIBS, is a scientific technique that analyzes the composition of materials by exposing them to intense laser pulses. Now, a high-energy laser pulse is focused onto the surface of a material, such as a rock or soil. The laser pulse generates an extremely hot and localized plasma. The spectra of collected plasma light is then analyzed spectrally. And since each element emits a characteristic set of wavelengths of light when it is in a plasma state, the elemental composition of the material is then determined.
Now, these in situ measurements confirm the presence of sulfur in the region absolutely unambiguously. Early analysis shown in this graph have unveiled the presence of aluminium, sulfur, calcium, iron, chromium, and titanium on the lunar South Pole surface. Further measurements have revealed the presence of manganese, silicon, and oxygen. Now, the search for presence of hydrogen is still continuing. Chandrayaan probe called CHAPEA, or Chandra's Surface Thermophysical Experiment, has measured the temperature profile of the lunar topsoil around the pole to understand the thermal behavior of the moon's surface. Now, it has a temperature probe equipped with a controlled penetration mechanism capable of reaching a depth of 10 centimeters beneath the surface. Now, the probe is fitted with 10 individual temperature sensors. The presented graph illustrates the temperature variation of the lunar surface at various depths during probe's penetration. Now, ISRO showed the sharp difference in temperatures just above and below the surface. The temperature on the surface was nearly plus 60 degrees Celsius and plummeted sharply below the surface, dropping to minus 10 degrees Celsius at just 80 millimeter, and that's about 3 inches below the ground. Now, the moon, however, is known for harboring extreme temperatures. According to NASA, daytime temperatures near the lunar equator reach a boiling 250 Fahrenheit or 120 degrees Celsius, whilst night temperatures can plunge to minus 208 Fahrenheit or minus 130 Celsius degree. Now, the moon's poles are even colder. One crater near the North Pole recorded minus 410 degrees Fahrenheit or minus 250 degrees Celsius, which makes it the coldest temperature measured anywhere in the entire solar system. Equally cold temperatures have been recorded at some of the craters, which remain permanently in the shadows in the South Pole.
In Europe now, HyImpulse launch opening window of his SR-75 rocket starts on the 1st of December from Saxo Voord in Shetland. Now, the UK Civil Aviation Authority approved HyImpulse launch. It would be the first launch out of Saxo Voord spaceport in Scotland. So this is the very top area of Scotland in an island, effectively. Now, the launch window is 12 months long. Now, what is this rocket? So the single-stage suborbital SR-75 rocket is powered by one of the HyImpulse company's HyPlox 75 hybrid rocket motor, which is capable of producing 75 kilonewton of thrust. Now you see the picture of this rocket. Now the rocket is designed to carry a maximum payload of 250 kilograms and reach altitudes of up to 200 kilometers. So very low Earth orbit, extremely low. Now this version of the rocket is a test article for a much larger rocket designated as the SL-1 for orbital use. In fact, the civil UK aviation authorities clarified this week that Saxo Voord will not need a spaceport license for that very first launch of this HyImpulse SR-75 rocket. Now the reason being was explained to be linked to two factors. Now, the first factor is the flight altitude, expected to be below 50 kilometer altitude. So the remote location of the islands and its vast sea around it, as well as the low population level in the island, is allowing the UK CAA to permit such a flight, as it bears low risks of population casualties. Now, the second factor is related to the engine or thrust limitation imposed on the rocket, here being around 80 kilonewton, ensuring a limited journey of the craft in the event of uncontrolled behavior. This week we saw the preparation of the second flight for the Starship plus booster prototypes. We're talking about Booster 9 and Starship 25, where you see the stabilization devices being removed from the OLM, as well as his air conditioning tubes. And also explosives have been received. These are for the flight termination system. Now you also see the ship 29 and 30 in the high bay being progressed. And also Starship received a mega press similar to that of Tesla, where they intend to use it for speeding up their manufacturing process. And last, the series of foundation are being prepared. I assume this is one of the 63 conditioned by the FAA to get the license for flying, and therefore this is probably what protects the environment around the base from debris and so forth. Finally, the week at Starbase ends with the transport of Ship 25 from the manufacturing site all the way to the launch site, where it is installed on top of Booster 9, ready for flight, pending and waiting, of course, the FAA license. So let's stay with SpaceX. This week we also saw the Crew 6 team, who was staying in the ISS for the last 6 months, has finally undocked and approached and landed in the Gulf of Mexico safely, and then repatriated back to Florida, Cape Canaveral. This week it was the Ariane group turn to do some testing. So they have tested their upper stage in DLR in Germany, which went very well, and they have also carried out a static fire of their center core in Kourou in French Guiana, which also went well. The group have mentioned that they will have to do another test in October, mid-October, at which time they will propose a launch date. This section is about preparation for a Mars and Moon base. So 2 months ago, 4 volunteers have entered the Mars Habitat Simulating Life on Mars, and sponsored by NASA. The experiment will last 12 months, and I will continue bringing you updates whenever available on how the experiment is coming along. So the first crew to leave and work for a year in a Mars-run ground-based simulated Mars habitat won't have the luxury of fresh food deliveries, but they will have the chance to grow some fresh produce. NASA's Crew Health and Performance Exploration Analog, also known as CHAPEA, Mission 1 crew began their mission June the 25th at NASA's Johnson Space Center in Houston, after several weeks of training to acclimate and habitat life and mission operation, as well as safety, communication, and team dynamics. So during the 1-year mission, the 4-person crew, science officer Anka Celariu, flight engineer Ross Brockwell, Commander Kelly Haston, and medical officer Nathan Jones will carry out different types of missions, including testing various food systems and some crops growth experiments, along with other activities such as simulated walks or Mars walks, robotic operation, habitat maintenance, personal hygiene, and exercise will test the endurance and impact of isolation on the crew. Now, NASA also intends to have 2 other 1-year ground-based missions to continue preparing for a Mars crew mission. That was your week in space and related space topics. Please do not hesitate to click on the subscribe button and select all notifications to receive the next video. Thank you very much for your loyalty. I am Christophe Paget. I bring space news to the grown-ups and captivate the interest of the little ones about space. Thank you. See you soon.